Here are two example problems from AP Physics on the topic of fluids. In the first problem, we see a picture of a rock inside a bucket of water, and it says that there's an upwards buoyancy force F0. And then it says that it replaces the water with oil, which has a different density. It asks us to calculate the new upwards force when the density is 3/4 the density of water. This question is about the buoyancy force and the buoyancy force formula. So here we have my picture. There's a rock in the water, and there's a force upwards. This upwards force is going to be the buoyancy force, and we should just write down the buoyancy force formula. One of the tricks to helping figure out these proportional questions is looking at the equation, and I like to literally write it down and look at it. So F0 is rho GV. That rho is the density of the water, and that's what's going to change. G is the same, and V is the volume of the block or the volume of the water that's displaced. So this volume is going to be the same between the oil situation and the water situation. So we can rewrite this formula for the oil. So the only thing that's different is that the rho is now 3/4 rho. That is 3/4 the density of water. Now, if I am clever, I can take the 3/4 out and write it like this. So I can say this second force of buoyancy upwards is 3/4 rho Vg, but that is just F0. Look at that. This is exactly the same as F0. F2 is going to be 3/4 times F0. This is to say that if the density is 3/4, then the buoyancy force upwards will be 3/4. The correct answer is A. The best way to improve your grade is with a practice test. On my site, I have free practice tests, including one on the topic of fluids. Here in the second question, we have a pipe, and the pipe has two sections, a narrower section with radius r and a wider section with radius 2r. And it says if we compare the velocity of the narrow section, what will the velocity of the wide section be? The way this question has worded it is asking us to write it as a ratio, Vy divided by V narrow. Again, we want to start with a formula. In this case, we need the flow formula. The narrow area times the narrow velocity is the wide area times the wide velocity. Now let's just arrange this in a way that we have Vy divided by V narrow, like this. So velocity y divided by velocity narrow is going to be area narrow divided by area wide. So we just plug pi r squared on the left side there. Pi r squared divided by pi 2r squared. And when we square this, we're going to get 4r squared on the bottom. That's great. We cancel all this, we get 1/4. The correct answer is A.